So we've been talking about triangles for most of geometry, and we're going to be moving on to quadrilaterals in this next unit. And I want to start with what is the sum of the measures of the interior angles of any triangle? And you all know that that's 180. But what would that be in any quadrilateral? And do you think that this sum can be determined given the number of sides of any polygon? So let's look at that a little bit closer for a minute. All right, so we know that the number of sides in a triangle is 3. And we know that the number of triangles that there are is 1, and that the sum of the interior angles is 180. But if I have a quadrilateral, which means we have 4 sides, and then if I split that quadrilateral into triangles, so now I have 2 triangles. So if I have 2 triangles, then I'm going to have 180 in each of those, so that's going to be 360 degrees. So to answer our question, the number of or the degrees in a quadrilateral is 360 degrees always. All right, but let's try to extend that to any polygon. So let's see what happens if I do a pentagon. So pentagon, I make a triangle there, and I can make a triangle there, so that's a total of 3 triangles. And then if I add those together, then that'll be 540 degrees. All right, so I don't know if you see a pattern forming, but a hexagon would be 6 sides, and that means there would be 4 triangles, and then that would be 720 degrees. So we could keep going, right? This would be 7, 5, 720 plus another triangle would be 900, all right, and so on. So then what is the pattern? So whatever the number of sides, so an n-gon has n sides, the number of triangles, if you notice that there's always 2 less than the number of sides. So we would have n minus 2. And then to get the degrees, we're just taking this number of triangles and multiplying it by 180. So that's what we use to find the sum of the interior angles of any convex n-gon. All right, so that's your formula that you're going to be using. So let's do that. So here we have, let's see, how many sides do we have? 1, 2, 3, 4, 5, 6, 7. All right, so this is a heptagon, which means that we would have 7 minus 2 times 180, and we just did that, right? So 5 times 180 is 900. So we know there's 900 degrees total in this polygon, in this heptagon. And then I'm just trying to find this remaining angle measure, so I can add up all of these angles. All right, so if I do 160 plus 150 plus 150 plus 110 plus 130 plus another 110, I'm going to get 810 degrees. So now I'm just going to take my 900 degrees and subtract that. That's going to give me 90 degrees. So this is a 90-degree angle right here. But we can also do things like this. The measure of the sum of the interior angles is 1620 degrees. So how many sides does this polygon have? So now we're going to go backwards. Now we know the answer is this, and we're trying to solve this for n. So what would we do? Well, I know I would divide it by 180. So 1620 divided by 180 is 9. And then we have to add 2. Remember, 9 is the number of triangles, so we'd have to add 2. So our n is going to be 11. So this is an 11-gon. All right, and then here it says find the measure of each angle in a regular 11-gon. Well, we're told that an 11-gon has a total of 1620 degrees in the interior angles. So if it's regular, that means all of them are going to be the same. So how many angles are there? Well, there's 11. So I'm going to do 1620 divided by 11. And that's going to give me 147.27 repeating. All right, so that's the degree measure of each angle and an 11gon. So your corollary then is if you know the degrees number of the interior angles, you can just divide by the number of sides, and that'll be what each angle measure is. All right, but what about the exterior angles? So we've talked about interior angles, and we've talked about exterior angles with triangles, right? We would talk about how the exterior angle is equal to the two non-adjacent, but also remember that an exterior angle makes a linear pair with this angle. So if this one's 30, this one's 150. Okay, so that's important. So we can do that with any polygon, but let's look at what do all of the exterior angles add up to be. And I'm going to do this in general. So I'm going to extend the sides. Notice that I'm extending the sides in the same direction. Okay. So let's say I don't know if it's an equilateral triangle or anything, but so I'm just going to label them X and Y and Z. These are the angle measures. Okay. What do we know about X, Y, and Z? Well, we know that they all add up to be 180 degrees, right? We know that of a triangle, and we could do that for any polygon, right? Because we would be able to find the sum of their interior angles. All right, but now their exterior angles, remember we just said that that's a linear pair of that. So this would be 180 minus Y, this would be 180 minus Z, and this would be 180 minus X. Okay, so I want to know what do all the exterior angles add up to be. So 180 minus X plus 180 minus Y plus 180 minus Z. I want to know what that simplifies out to be. So if I combine my like terms, my constants, I'm going to have 180 plus 180 plus 180, which is 540. But then these do not combine, right? I still have a minus X, a minus Y, and a minus Z. So that as is doesn't really help me. But notice that all of these have negatives in front of them. So I could, if I wanted to, I could factor out a -1, right? And then that would turn the X to a positive X, and then a positive Y, and a positive Z. Now, why would I want to do that? Well, because I know that X plus Y plus Z is equal to 180. So I can substitute that in. So I'm basically doing 540 minus my 180. Okay, so 540 minus 180 gives me 360. So you might think, well, that's true for a triangle, but that doesn't mean it's going to work for any polygon. Well, what would happen if I had a quadrilateral? If I had a quadrilateral, again, I wouldn't know the degree measures, but I would just have one more angle, right? So I might have, let's do W. So I have 4 angles, right? W plus X plus Y plus Z. Okay, and we just said in our interior angles that a quadrilateral, those interior angles add up to be 360. So now we're not doing 180, they all add up to be 360. All right, so what about the exterior angles? The exterior angles would look like 180 minus W plus 180 minus X plus 180 minus Y and then 180 minus Z. So what would all of those add up to be? Well, now I have 4 180s to add up together. So that would be 720. And then I would have my minus W minus X minus Y minus Z. Do you see the pattern here? So now again, I could factor out that negative and I'll have these added. So I'll be subtracting from 720 the interior measure of their angle, so that would be 360. So what do I get? I get 360 again. Okay, so think about what's happening. Every time I add a side, I'm adding an angle measure, which adds a 180, and then I'm also adding 180 because I've also added the interior angles. That's another triangle. All right, so it's always going to end up being 360. The sum of the measure of the exterior angles will always add up to be 360. And then, of course, a corollary to that is if I have a regular polygon or n-gon, then the exterior angle, each exterior angle will just be 360 divided by n, however many there are. So let's do some problems. All right, we're going to try to find the missing angles. So we have Measure of angle 2 is 100 degrees. 8 is 40 degrees. 4 and 5 are 110. Okay, so then what can we conclude about that? Well, each exterior angle makes a linear pair. So this is 70 degrees. 3 is going to be 140. 7 is going to be 80 degrees. And then we still have to find 1 and 6. We know 1 and 6 will be a linear pair, but we need to find either 6 or angle 1. And you can do this either way. Now, they didn't label this one. Let's go ahead and label this one. Let's label it 11. All right, so I know that 11 would be, this would be 70 degrees also. So we can either add up all of the exterior angles and find that missing one, or we can add up the interior angles. For me, I know that exterior angles is always 360, so I don't even have to worry about the number of sides. So let's find out that missing exterior angle. So I already have 80, so I'm going to be adding 80 plus the 40 plus the 70 plus the other 70. So what does that give me? 80 plus 40 plus 70 plus 70. All right, that's going to give me 260. All right, so that means I still have 100 degrees left for this remaining exterior angle. And then from there, I know that 1 has to be in a linear pair with that, so that should be 80 degrees. Now, if we were going to do 1, we would have to find the degrees of this polygon, which is a 1, 2, 3, 4, 5, a pentagon. So we would have to calculate the interior angle measures of the pentagon first, and then find the angle 1. One more that I wanted to talk about is this one. The first and second angles of a triangle have the measures in a ratio of 2 to 3. So let's draw this out. I have a triangle. I don't know what kind of triangle it is, but I'm going to call this, let's see, we'll put first, second, and third, just so we can keep that straight. But it says the ratio of the first and second is in a ratio of 2 to 3. And remember, when we have ratios, we don't know that it's 2 degrees or 3 degrees, so we have 2x, 3x. So the third angle is 4 degrees larger than the second. All right, so the second is 3x, so we know that it's going to be 3x plus 4 there. Okay, so we're going to find the measure of an exterior angle at the third vertex. So we're going to be looking for this exterior angle right here. Okay, so first we need to find x. Wouldn't you agree? So we know that 2x plus 3x plus 3x plus 4, those should total to be 180, right? That's the interior measure of a triangle. So we combine our like terms, and we're going to get 8x plus 4 equals 180. 8x then would be 176, and 176 divided by 8 would be 22. All right, so if I plug that back in here at the third spot, 3x plus 4, so that's going to be 66 plus 4. That means the third angle is 70 degrees. And so our exterior angle is going to be a linear pair with that. So our exterior angle is 110 degrees. Okay, so it helps to draw that out, label that with the 2x and the 3x, and then do your calculation. And remember, triangle is not unique anymore. We could do this with any kind of polygon now that we can find the sum of their interior angles. Same thing with exterior angles.